Hi, I'm Jackie Knowles of Glasswork Pixie, partnering with Oceanside Glass and Tile to bring you this instructional Fusing Fundamentals video series. You're joining me for Lesson 7, where I'll go over the different methods you can use to prepare a kiln shelf for firing. I'll also introduce you to molds and explain how to prep those as well. As glass is fired, it gets soft and sticky and will attach to whatever it's touching. Because of this, a separator is always required between glass and the surface it's fired upon. Without a separator, glass may attach to a kiln shelf or mold, and then usually can't be removed without irreparably damaging that surface. There are several different types of separators that can be used with shelves and molds. Shelf paper is one potential separator you can use. Varieties include fiber papers made from aluminosilicate and ceramic-based papers. Both are specially formulated for use in high-temperature environments, but fiber papers come in several different thicknesses, while ceramic-based papers are usually very thin. Setting up shelf paper is super simple. To do so, cut a piece large enough for your project to fit on, and then place it on top of the kiln shelf. The project can then be constructed on top of the paper. When sizing a shelf paper cut, remember the 6mm rule discussed in Lesson 4. If the glass is likely to expand during firing, be sure to leave a wide enough border of paper around the project so that it won't spill over onto the kiln shelf. And as mentioned in Lesson 6, vent the kiln slightly when firing with fiber paper to allow the resulting fumes to escape. After shelf paper has been fired, it will degrade due to the extreme temperatures. With very thin paper, this will happen after a single firing. Thicker papers may be able to be refired several times before breaking down enough to no longer be functional. Fired shelf paper can be removed from kiln shelves by hand and thrown away. Since it becomes an easily airborne dust, a respirator with particulate filters should always be worn during this process. I also recommend wearing gloves and even goggles to further minimize chances of particles getting onto your face or hands and then being ingested. If any fragments of paper stick to the glass after firing, use a scrub pad to gently detach them. Keeping the glass and pad wet during this process will help reduce floating dust particles. The main advantage of using shelf paper is the ease and speed at which it can be applied, manipulated, removed, and reused if it's thick enough. Additionally, the thinnest types of shelf papers have very minimal texture and will leave glass with a smooth finish after firing. Thick shelf papers also create a permeable layer underneath the project that provides avenues for trapped air to easily escape, helping prevent bubble formation. This, along with its simplicity of use, makes shelf paper a great choice for beginners. One potential disadvantage is that thicker fiber papers almost always leave a slight visible texture on the glass surface post-firing. Since some material burns off of fiber paper at high temperatures, it may also introduce risk of devitrification, as we saw in Lesson 6. An alternative separator to shelf paper is shelf primer. This is typically a powder consisting of several refractory substances such as alumina, kaolin, and silica that can be mixed with water and then brushed onto surfaces. When working with shelf primer in its powdered form, which includes both mixing it pre-firing and scraping it off post-firing, do so in a well-ventilated area and wear a respirator with particulate filters. Just like when removing fired shelf paper, I also recommend wearing goggles and gloves to further minimize chances of ingesting any dust particles that may be produced. To mix shelf primer for application, combine it with water in the ratio recommended by the manufacturer, which is typically about 5 parts water to 1 part primer. Stir the mixture thoroughly until there are no lumps of powder left. Once it's dissolved, use a soft bristle brush to transfer the shelf primer to the kiln shelf. An ideal tool for this purpose is a hake brush, but other wide, natural bristle brushes can work too. Give the bristles a gentle tug to remove any loose hairs before starting to prevent them from ending up on the kiln shelf. Dip the brush in the primer, wipe off the excess, and then paint it on in parallel strokes going in the same direction. After covering the shelf in this way, repeat the process in the perpendicular direction. Run the third and fourth coats diagonally from corner to corner. Apply the fifth coat in the same direction as the first, but starting from the opposite side of the shelf. And finally, apply the last coat in the same direction as the second, but again starting from the opposite shelf side. This application technique is important because in most cases, it's desirable for a shelf to have the most even, smooth surface possible so that it imparts minimal texture to the glass surface during firing. Be sure to wipe up any primer that's spilled around the application area to prevent it from drying into a dust that can become airborne and be inhaled. Once all coats have been applied, transfer the shelf to the kiln. Shelf primer must be completely dry before being used with a project, because any moisture left on the shelf will evaporate during firing, potentially forming bubbles between the shelf and the glass. Moist primer is also more likely to stick to fired glass and become difficult to remove. To thoroughly dry primer, fire it in the kiln according to the manufacturer's directions. This usually means ramping up quickly to around 550 degrees Fahrenheit, holding for about 20 minutes, and then cooling as fast as possible to room temperature. Vent the kiln slightly during this firing to avoid corrosion of the kiln's internal elements. Once the shelf has completely cooled, a project can be constructed on top of it. To remove fired primer, use a putty knife or similar tool with a thin, flat edge to scrape it off the shelf surface. Wet the surface first to minimize the amount of dust produced, and then make sure to scrape in an even, controlled manner from edge to completely remove the primer. A razor blade may be helpful for edges or any stubborn sections. And if any primer sticks to the glass itself, a scrub pad can remove it without scratching the glass. Remember to wear safety equipment during the primer removal process, and afterward, use a shop vac with a HEPA filter or wet wipe to clean up any dust particles that may be left behind. An advantage to using shelf primer is that it's much cheaper than shelf paper. With proper application, it also leaves glass with a very smooth finish, imparting little texture, and it poses no risk of triggering debit. Primer's biggest disadvantage is the time it takes to apply and clean up. Depending on the brand, it has to be removed, reapplied, and dried between every firing, which can really add up for frequent fusers. The exception to this is when it's heated to slumping and draping temperatures below 1300 degrees Fahrenheit, in which range it can be reused multiple times. The process of preparing a slumping or casting mold for firing with shelf primer is largely the same as for a kiln shelf. Several coats should be applied in the same manner as previously shown, with each coat running in a new direction. One difference from shelves is that mixed shelf primer tends to pool in the bottom of concave molds, especially casting molds. Take special care not to let it dry there, since an extra thick section of primer will not only affect the shape of the fired glass, but can also become difficult to remove post-firing. Slowly tilt the mold in different directions to help even out the coating. Another difference is that molds should always be slightly elevated within the kiln to promote even air circulation around them and to allow air to escape through their vent holes. When ready to fire dry a mold, use posts, dams, or other kiln furniture to prop it up a couple inches above the kiln floor. Ceramic molds also need to be kiln dried at a slower rate than shelves. Because they're composed of different material than shelves and have more complex and fragile shapes, Extra care needs to be taken to ensure they don't dry too rapidly, or they could crack. A typical firing schedule for drying a mold includes a 500 degrees Fahrenheit per hour ramp up to a process temperature of 500 degrees Fahrenheit with a 20-minute hold time, and then a 500 degree Fahrenheit per hour ramp down to room temperature with no hold time. Very small molds can be dried at a slightly faster rate, while large molds should be dried slightly slower. The last difference from shelves is that the tiny holes in ceramic slumping molds must be free of primer before firing. These holes provide pathways for air to escape, preventing the bubble formation we learned about in Lesson 4. After kiln drying a mold, use a pin or toothpick to clear its vent holes of any dried primer. Once this is done, the mold is ready for use. Draping molds are typically made of stainless steel instead of ceramic. We'll discuss exactly why that is up next in Lesson 8, but because of this difference in material, shelf primer doesn't adhere to draping molds as readily as slumping molds. To help primer stick, I suggest that before using a draping mold for the first time, you kiln fire it alone up to the process temperature you plan to use it at, which should be somewhere between 1200 and 1300 degrees Fahrenheit. This will not only remove any residual oils that may be left over from the mold's manufacture and cause devitrification, but it will also impart a slight texture to the surface, better allowing the primer to grip on. If you still find the surface too smooth to readily accept primer, you can try lightly sanding the mold with steel wool or 100 grit sandpaper to give it even more texture. Once the surface is rough enough, primer can be applied. Brush on the first coat in long, even strokes, and wait several minutes for the first coat to dry before continuing. Once it's dry, apply the second coat, brushing in the opposite direction as the first. Since steel is not porous like ceramic, there's no need to apply more than 2 coats. Once both coats have dried, transfer the mold to the kiln, making sure it's elevated on fiber paper or kiln furniture, and fire according to the primer manufacturer's directions, in the same way you do for a kiln shelf. Remember to vent the kiln slightly during this firing to avoid corrosion of the kiln's internal elements. Once the mold has completely cooled, it's ready for use with glass. To remove fired primer from molds, use a scrub pad to gently buff it off. Just like when cleaning shelves, keep the scrubber and surface wet to minimize dust creation. And also like with shelves, wear a respirator, gloves, and goggles during the removal process, and use a shop vac with a HEPA filter to clean the area when finished. Because slumping and draping molds are typically fired to low temperatures, primer doesn't have to be removed and reapplied between every single use like it does with shelves. The more sharply angled the sides of a mold, the more primer glass will pull away as it moves along their surfaces. So steep molds may need to be reprepped every 2 to 3 firings, while shallow molds can be reused up to 30 times or more. You'll know a slumping or draping mold needs to be reprimed when the degradation of its primer becomes visible. Casting molds, on the other hand, do have to be cleaned and reprimed after every use, since they're fired to much hotter temperatures and their primer will degrade much quicker. Just like with kiln shelves, thin shelf papers can also act as separators between glass and molds, depending on the mold shape. To prepare a mold with shelf paper, cut a piece of thin paper at least a 1/4 inch larger than the glass and center it over the mold with the glass on top. The paper will drape around the mold along with the glass as it fires, acting as a barrier to keep the two from touching. Fired shelf paper can be removed from molds by hand while wearing the necessary safety equipment, just like with shelves. I personally prefer to use shelf primer to prepare molds for firing, but many stained glass supply shops sell spray-on coatings that can also act as separators. Experiment with different materials to find the one that works best for you. Now that you know how to prepare and clean your shelves and molds, you're ready to use them to start bringing shape and life to your fired pieces. In the following video, Lesson 8, I'll cover the differences between slumping, draping, and casting, and I'll use a prepared mold to demonstrate the various glass forms each can produce.